So they say, what is the acceleration and in which direction will the body move? In this kind of problem, you have the first force and you have the second force. What are you going to do when you know that the force is given as just F equal to ma? Now with this, you get the students confused, even some teachers who are trying to understand the principle of force. Have a nice day. Welcome to this class. In today's class, we are going to talk about a very important topic. I call it misconception about force, and this is physics. I am very sure that both the students and the teachers are having problem with this topic and with this called force. And I have come for us to x-ray and solve the problem. And in this class, I'm going to focus on few subtopics. The first is the origin of force, and the second is its principle, and the third one is going to be the application of the force to problem solving. Now let's start with the origin of force. The origin of force is what we call force originated from a man called Sir Isaac Newton. Sir Isaac Newton. I hope I got that spelling correct. All right, and that is why whenever you are asked to solve force, the question is always given to you that the SI unit of force is Newton. That is why they say that F is equal to 5 and we put capital N, which is Newton, and this is the man. So that simply means that the problem about force was solved by the man Sir Isaac Newton, and his principle is what I'm going to talk about in this number 2. Now the question should be, what is the principle of force according to Sir Isaac Newton? Now, the principle of physics according to Sir Isaac Newton is traced to what we call second law of motion. According to Newton, we'll say Newton's second law of motion. That is where our problem started. You know, many people and many students and even teachers, they ask them, what is the second law of motion? In fact, most of the things you do in mechanics are centered on the second law of motion, especially when it has to do with the movement of a body and the force applied. And that principle is stating that according to Sir Isaac Newton, his law says, and according to Sir Isaac Newton, second law of motion says that, it says that the force applied on a body is directly proportional to the rate of change in momentum. Or you can simply say that the net force, that is the point I want to make in this video, that the net force applied on a body is directly proportional to change in momentum per time. That simply means that this F net is equal to K ma. Why do I say ma? Because V minus U all over T is acceleration. So if you do that, where we say that K is unity, is 1, we say that F net is equal to mass times acceleration. Now this is the problem. The problem is the fact that you do not understand the principle according to Sir Isaac Newton, the principle of second law of motion. And that is why you keep writing force as F is equal to mass times acceleration. If you are writing force as just force equal to mass acceleration, you are limiting the principle of the force, and that is where the misconception is. However, my correction to that problem is writing it like this, F net. It is better to be written as this, F net is equal to mass times acceleration, or you can put it this way, you can say that F sub r, which is resultant force, is equal to mass times acceleration. I know that this may be this is a vector and this is a vector. I can also say that I can write it this way. whereby I said sum of all the forces in one direction, in a horizontal direction, is equal to the mass times its acceleration. I can also go by saying that sum of all the forces on the vertical component must equal to mass times acceleration. Now, with this understanding, the question is, then somebody should be asking, then what is the difference between what you have written and this formula? You see, the problem is when you go into problem solving, when you are given a question to solve, and the question could be a body, a force of 5 Newton is applied on a body. Let me say, and this is a body, and a force of 5 Newton is applied on a body of mass. Let's say yes, force of 5 Newton is applied on a body of mass, let's say 10 kg. They say find the acceleration. This is very easy to solve because they gave you just F equal to 5 Newton, whereby you are going to say that F, in that case, you are applying this mass times acceleration. You say that 5 is equal to 10 acceleration. Therefore, acceleration is 5 over 10, which is 0.5 meters per second squared. All right, you are free, right? You are free. If it is like this, you are very free. What if the question comes this way? Force of 5 Newton is applied on a body, and the body experiences a frictional force, which is very normal that whenever there is a force applied, there should be a frictional force, no matter how small the frictional force should be. Let's say a frictional force of 2 Newton is applied on a body of 10 kg. So they say, what is the acceleration and in which direction will the body move? In this kind of problem, you have the first force and you have the second force. What are you going to do when you know that the force is given as just F equal to ma? Now with this, you get the students confused. Even some teachers who are trying to understand the principle of force, you get them confused. Because when I now introduce my own concept of force, which is net force equal to mass and acceleration, or you say resultant force equals to mass and acceleration, or you say sum of all the forces on the horizontal component is equal to mass times acceleration. In that case, you now start thinking, what is the meaning of net? Net means subtraction. When two things are not moving in the same direction, you do what? You find change. You find change. In that case, this is a retarding force or frictional force, which is 2 Newton, and this is a force applied on the body to pull it. But because it's experiencing a frictional force, there is going to be what is called net force. That means the final force with which the body uses to move in that direction. So what are you going to do? Net force in this case is going to be 5 minus 2, which is what? 3 Newton. This is the net force. We are going to now say that net force is equal to mass times acceleration. We have 3 is equal to 10 times a acceleration. Then acceleration is now moving with what? 0.3 meters per second squared. Now, in this case, you realize that the body's acceleration has reduced. Why? Because of the inclusion of this frictional force. And the truth is that many of these jam-related questions and wire-related questions, they are not coming as just a singular force. It is coming such that you are going to find a net or resultant force. Whereby you now say that 2 or more forces apply on the body, you must find the resultant force, or you must find sum of all the forces in one direction, which is sometimes we call the algebraic sum of the body in a given direction. You see the reason I told you using this formula is deceptive when we are talking about force. Let me show you another example. Let me use this small space to give you an example. Let's assume a body of mass 10 kg is pulled on a horizontal with a force of, let's say, 5 Newton to the angle 30 degrees to the horizontal. And the question is, what is acceleration? At this point, you are given 5 Newton and the mass. Every student who is coming to physics for the first time, and who knows that force is all about F times mass as acceleration, is going to say, oh, like some physics teachers used to say, list the parameters given. You say F is equal to 5 Newton, right? And then mass is what? 10 kg, right? Then to find acceleration, is it not going to be that 5 is equal to 10 times acceleration? Therefore, acceleration is what? 0.5 meters per second square. But this is wrong, because this F must be explained to the students, for the student to know that this F is not just F. It is either net force, resultant force, or algebraic sum of the forces in a given direction. And if that is going to be taken into consideration, then I should be thinking that this cannot be solved except I use this formula. What does that mean? Resultant force. That means this force, which is inclined at an angle 30 degrees, must be resolved to the horizontal, depending on the direction of the motion of the body. If the body is moving in this direction, then I'm going to resolve this to the horizontal, whereby the force, resultant force, is going to be what? That is the resultant force is going to be 5 times cos 30 degrees. That is the resultant force, because I have resolved this to the horizontal. The reason and how I got to 5 cos 30 degrees is going to be explained in another video. But in this case, I'm going to have 5 times 0.8660 is equal to, mass is 10 times what? Acceleration. Therefore, A is equal to, this is where you now find the acceleration. So, if you had been seeing force as just F equal to mass as acceleration without a proper interpretation of the meaning of that force as a student, or you are a teacher who has been teaching your students that force is just F equal to mass and acceleration, then I think after this video, you need to rethink and start teaching it in the proper way, or you start learning it in the proper way. However, let us do a recap. I said that the origin of force came from Sir Isaac Newton. I hope this spelling is correct. Yes, Sir Isaac Newton, he is the one that gave us an interpretation of what force is. The first. And according to him, the principle or the law is Newton's second law of motion, which says that applied force, or the net force, is directly proportional to the rate of change in momentum. Sometimes we add and moves in the direction of the force. And with that, we now came across F net is equal to mass and acceleration. And the application of the problem solving is what I have just explained. So whenever you see a force, you should be thinking of resolution of the forces involved in the movement of the body and its acceleration. Thank you very much for being part of this lesson. Remember the right thing to do. Hit the subscribe button, like this video, share it, and comment. Have a nice day.